A Category 5 storm's closing in. On the deck sits more than $5 billion worth of aircraft fully exposed. One mistake can turn a $70 million jet into ocean debris. This is how aircraft carriers protect billion-dollar aircraft during extreme storms. A modern aircraft carrier is not just a ship, it's a floating air base, and on its deck sit dozens of fighter jets, radar planes, and helicopters. A single FA-18 Super Hornet costs roughly $70 million. A carrier can hold more than 60 of them, putting over $4 billion in aircraft on an open runway at sea, more air power than many countries possess. And yes, these aircraft live on a moving runway in the middle of the ocean, right where storms grow strongest. Hurricane season lasts for months. From early summer through late fall, carriers can't simply hide. They operate every day in every ocean, no matter the weather. What's dangerous isn't the storm itself, but what happens if preparation fails. The first layer of protection starts long before a storm appears on radar. Every aircraft on a carrier has a planned parking spot. These positions are chosen carefully based on safety, wind exposure, and access to elevators. Nothing is random. If an aircraft is parked in the wrong place, heavy seas can push it into another jet, causing a chain reaction of damage. Below the flight deck sits the hangar bay. This space is like a massive steel garage. It stretches hundreds of feet long and spans most of the ship's width. Heavy steel doors divide it into sections. These doors are designed to stop fires, but they also add strength during violent weather. When a storm is approaching, commanders decide which aircraft can be moved below deck. Priority goes to the most valuable and sensitive jets. If space allows, dozens of aircraft are lowered into the hangar bay using giant elevators. These elevators can lift multiple jets at once, even in rough seas. A delayed decision here can leave aircraft trapped topside when winds become too dangerous to move them. Inside the hangar, aircraft are protected from wind, rain, and waves. Panels are closed, canopies are locked, and every surface is checked. Salt water can destroy electronics quickly, so sealing the aircraft matters as much as moving them. One unsecured panel can flood sensitive systems and ground an aircraft for weeks. But not every aircraft can fit below deck. Space is limited. Some jets, helicopters, and support planes must remain on the flight deck. This is where losses usually happen. Aircraft on deck are held in place by chains, not ropes. These chains are heavy, solid steel. Each one hooks into strong points on the aircraft and locks into steel fittings welded into the deck. On calm days, jets use 4 to 6 chains. In storms, that number can triple. If even one chain fails, the aircraft can begin to slide as the deck tilts. Chains are placed in a cross pattern, forward and backward, left and right. This keeps the aircraft from sliding in any direction. Every chain is pulled tight, then checked again. Slack is dangerous. One loose chain can turn a 30,000-pound aircraft into a rolling projectile. And this isn't just theoretical. In July 2022, an FA-18 Super Hornet was torn loose from the USS Harry S. Truman during heavy seas and fell nearly 10,000 feet into the Mediterranean. Investigators found the securing procedures had failed. Sailors who handled this work trained constantly. The deck crew wears colored jerseys that show their roles. Blue shirts secure the aircraft. Yellow shirts guide movement. Others handle fuel, safety, or rescue. During storm prep, these teams move with speed and focus. Winds are already rising. The deck is pitching. Rain reduces visibility. Every extra minute increases risk, but the work continues. Wings are folded to save space. Many Navy aircraft are designed with folding wings for this reason specifically. Folding reduces width and lowers the chance of contact during heavy motion. If wings aren't folded in time, aircraft can strike each other as the ship rolls. The Navy learned this the hard way. In 1944, a U.S. carrier group sailed straight into a massive typhoon in the Pacific. Winds tore aircraft from decks. Fires broke out. 3 destroyers sank and hundreds of sailors were killed, not by the enemy, but by the storm. Because of disasters like this, modern carriers now used reinforced tie-downs, stricter weather thresholds, and mandatory storm drills. The carrier itself also fights the storm. These ships are built for stability. Their weight is balanced, so they naturally want to return upright when tilted. Their wide hull spreads force across the water. Deep below, powerful systems help control movement. During storms, the ship turns into the wind. This reduces the force hitting the deck. Waves are met head-on instead of from the side. Speed is adjusted carefully. A carrier taking waves broadside risks sliding aircraft and structural damage. The bridge watches weather data non-stop. Modern carriers also receive constant updates from satellites and weather aircraft. They track wind speed, pressure, and wave height. Storm paths are updated in real time. Decisions are adjusted as conditions change. Communication here is critical. If the ship turns suddenly, the aircraft must be secured more tightly. Crews below deck need a warning. One missed message can undo hours of preparation. Past accidents have shown that silence or delay can cost millions in seconds. As storms intensify, watertight procedures begin. Doors are sealed, hatches are closed. The ship becomes a steel box. Water that reaches the deck must drain quickly. Drainage channels prevent water from pooling. Sometimes, storms don't come alone. In recent years, carriers have faced bad weather while also operating in combat zones. Crews may need to secure the aircraft for wind, then suddenly maneuver to avoid threats, then re-secure everything again. Each maneuver risks loosening chains and shifting aircraft. This is exhausting work done under heavy pressure. Even when aircraft are lost, investigations follow. The Navy studies every failure. Was it a mechanical issue? A training gap? A communication breakdown? Changes are made. Training increases. Procedures tighten. Losses directly reshape how future storms are handled. The hardware also improves. Tie-down fittings are inspected and replaced often. Salt and wind wear metal down. These fittings are load-tested regularly. Each one must withstand roughly 16,000 pounds of force. If one fails, it's removed. The cost of replacing steel is nothing compared to losing a jet. Sailors face extremely harsh conditions. Deck temperatures can soar under the sun or drop sharply in cold storms. Winds can knock people off balance. Rain stings. Noise never stops. Yet crews keep working. Many are barely in their 20s. They rely on training and teamwork. Above the deck, officers coordinate every movement. Models track aircraft positions. Checklists give actions. Final inspectors verify chains and locks. Skipping one check can cost $70 million in seconds. No step is skipped. After the storm passes, the work's not done. Aircraft are inspected for damage. Water intrusion is checked. Corrosion is cleaned. The deck itself is examined. Systems are tested before flight resumes. Only when everything is verified do operations continue. What makes aircraft carriers unique is not that they survive storms. It's that they keep operating through them. Flights resume. Missions continue. Readiness is maintained. Storm survival's not sheer dumb luck. It's planning, engineering, discipline, and people doing hard jobs correctly every time. One missed chain, one missed call, one ignored warning. That's all it takes to lose a $70 million aircraft. Carriers don't defeat storms. They survive them by eliminating mistakes. And at sea, mistakes cost millions.